Hello everyone, my name is Abhishek and welcome back to my channel. Today is day 3 of Terraform Zero to Hero series, and in this video we will deep dive into one of the most important concepts of Terraform, that is modules. Please watch this video till the end because we will not only cover the theory part, that is scenarios, advantages of using modules, but we will also do an end-to-end demonstration. That means we will write a regular Terraform project and then we will convert that into a Terraform module. So it's going to be interesting. So please watch it till the end. Before we do that, let's quickly recap what we have learned as part of day 2. So as part of day 2, we understood what is a provider in Terraform in detail. We learned how to use multiple providers in a single Terraform project. That means using one Terraform project, how can you automate multiple cloud infrastructures or multiple providers? Then we have learned about the concept of multiple regions where we can use Terraform to automate infrastructure in two different regions, or you can set up a multi-region architecture using Terraform. Then we have learned about the concept of variables. We understood what are variables, what are output variables, how to use TF-vars, how to pass the values to the variables. So these are all the things. And finally, we learned about conditional expressions in Terraform. So please again watch it till the end because we will use all of these things in today's video to create the initial project, and using the concept of modules, we will convert this entire project into Terraform module. Okay, let's start with understanding what exactly is a module in Terraform. Let's take a real life example so that you understand this in a better way. For example, you are working in an organization and this particular organization has some millions of lines of source code. Let's say this source code is written in Java and the name of the company, for instance, let's call it as Amazon.com. We all know that these days every company is using the microservice architecture. But for an instance, let's assume that this company is using a monolith application or monolithic architecture. What does that mean? All 1 millions of lines of code is written as a one single application or one single project. Now, you might be thinking that, okay, everything is written as part of one single application. What is the problem? Now, the problem would be, let's say there is a bug on this particular application. And there is a new person who has just joined the team and you have assigned this new person with this particular bug. So this person would take ages to understand where exactly the bug is, or this person would take a lot of time to firstly read the entire 1 million lines of code, because there is a bug and technically it is not easy to understand where exactly the bug is. So this person would end up spending a lot of days to just understand where the bug is. And second thing is there would be lack of ownership, right? So let's say again there is a bug and you want to assign this particular bug to any particular developer and tell them that, okay, try to fix this bug because this is created due to the code or due to the changes that you have implemented. That would be not possible because there can be hundreds of developers writing this millions of lines of code, and you cannot say exactly that who owns which part of the code. Like you cannot say that, okay, out of 1 million lines of code, first 10,000 lines is owned by X developer, 10,000 lines is owned by Y developer, or in this 1 million lines of code, there can be some 1,000 functions, right? It will be not easy to say that first developer owns 10 functions, the other developer owns the other 10 functions. So there will be a lack of ownership. And third thing would be maintenance would be very, very difficult thing. What does that mean? Let's say you want to keep upgrading this particular application, right? You want to make sure that this particular application does not have any security vulnerabilities. So the problem is, again, because this is one single application, has millions of lines of code, it is practically it creates a lot of challenges to maintain the application. So to address all of these things, and beyond this, there is another simple thing, that is, let's say you figured out the bug as well and you try to fix this thing. Now to test this particular piece of code, right, which part of the application would you test? Because it is one single application, you will test the entire application and you will deploy the entire application. So testing would also be very, very difficult. So to address all of these things, what developers have done, or what the software industry has done, is they have transitioned from the monolithic architecture to the microservice architecture. Now you might be wondering, but Abhishek, why are you telling us all of these things in today's video? So it has a great relation. The same thing happens with Terraform as well. Let's try to understand how. So even with Terraform, there will be one particular provider that you try to automate, right? So usually these days in companies, mostly there will be one single provider, but at cases, if you are working in a hybrid cloud architecture, you might work on multiple providers as well. But for the purpose of video, let's say that in your organization, you are using AWS and you are using Terraform to automate the AWS. Okay. And let's assume that you just use one particular Terraform project. Okay. There can be hundreds of development teams, but let's take example of only one development team. Okay. Even for one development team, as a DevOps engineer, you might create a lot of resources, right? Just one single development team can use VPC, EC2 instances, they might use load balancers, they might use EKS clusters, Lambda functions, S3 buckets, everything that we have learned as part of AWS Zero to Hero series. Now, if you try to put all of these things in one single Terraform project, I'm not even talking about multiple development teams. I'm only talking about AWS DevOps engineer supporting one particular development team. If that particular DevOps team creates only one Terraform project, okay, if you create only one Terraform project for all the requirements of this development team, let's call this development team as XYZ development team. So your Terraform project will increase leaps and bounds. That means your Terraform project will end up similar to this monolithic application because you have everything in one particular Terraform project. So to solve this problem and to address all of these challenges exactly the same, let's say you created the Terraform project and you found bug in the Terraform project that you have created, right? How will a new person understand where to go? Who owns that Terraform project? Because that Terraform project would also have some thousands of lines. Of course, it will not have millions of lines, but there can be some thousands of lines. And how do you maintain this particular Terraform project, right? And finally, how would you test it? Again, this is very, very important because let's say you created a particular Terraform project and in the main.tf file, okay, in the main.tf file of the Terraform project, you wrote logic for all of these things, right? And you want to fix a bug with respect to EC2 instance. So one of the DevOps team member, okay, would create a pull request on the GitHub repository addressing changes for this EC2 instance, but it is in the same main.tf file. Probably you are making some changes to the variables, okay, and to test if this variable has impact to the other things or not. Or sometimes this can become very, very tricky. Some of the components can be interrelated, okay. You might be using same subnet for different resources. So it is important to not create everything in one single thing. And here developers are following an approach called microservices, whereas as DevOps engineers with respect to Terraform, you will follow an approach called as modular approach, or this particular concept in Terraform is called as modules. So don't worry, I'll explain you how to use these modules, what exactly these modules are. If you have an existing Terraform infrastructure, how to convert that particular infrastructure to modules. We will learn about all of these things. But here, you need to understand this particular concepts because they can be asked as scenario based questions, or during the theory part of your DevOps interview, you might be asked these questions. So that's why what I've done is, apart from these things that I've mentioned, you can also go to the GitHub repository, and in the GitHub repository, you will find a document called modules.md. And here I have mentioned about the reasons. So what are the reasons? One is modularity, which I've talked about. Second is reusability. Of course, the advantage of the reusability in this case would be, let's say that instead of writing this entire thing as one single project, if you write EC2 as a module, okay, you will get the ownership for one particular DevOps team member. You will get the maintenance done very easily. Along with that, let's say there is another particular development team called ABC, and they also need logic for EC2 instance creation. So what you can do is you can use this particular module that you have written, okay, to the development team ABC and XYZ. Right? If you write it as one single Terraform project, everything in the main.tf file, and if XYZ team and ABC team, like XYZ team, they have requirement for uh, EC2 instance plus VPC plus blah blah blah, and here they just need, for example, only an EC2 instance. So if you are modularizing this particular Terraform project, out of all the things that you have written for them, you can just take the EC2 instance code and you can utilize for the ABC team, right? So that is called the second thing, which is called as reusability. Simplified collaboration, which we talked about, versioning and maintenance, abstraction, testing, documentation, scalability, security, which we discussed, right? When I explained about microservice architecture, I covered about all of these things. And you can also go through this entire MD file so that you can be ready for your interviews and you can explain them what are the advantages. Now, let's try to put these things in action. Like I told you, we will do the demonstration. And as part of the demonstration, firstly, I would create a Terraform project with the things that we have learned as part of day 2. That means I'll create a proper Terraform project using variables, using TFRs. We will create resources on AWS, and then we will learn how to modularize it. Okay, so let's get started. For the purpose of the demonstration, I will use code spaces. I have explained in the first video how to create code space, how to configure it, how to set up Terraform and AWS. And it comes with 60 hours of free time. So I thought I will utilize it, and people who don't have proper resources, it will be easy for them, right? So that's why I'm doing it in the code spaces. And firstly, what I'll do is I'll just show you that Terraform hyphen version, Terraform is properly installed. Then AWS hyphen version, AWS is okay. The Terraform spelling is wrong. AWS is installed, and now let's see Terraform as well. Terraform hyphen version. It is also installed, right? And let me delete if there is any Terraform infrastructure. So I'll use Terraform destroy, and you will see that there is no Terraform infrastructure that I have previously created. Perfect. Now let's switch to day 3. So what I'll do is, in the day 3 folder, by the end of this demo, you will see the files uploaded. When you watch this video, all the project that I'm creating would be part of day 3. So let me create a new file here so that I'll start everything from the scratch. So firstly, I'll write this main.tf, right? And inside main.tf, what we will do is we will try to create a EC2 instance using all the concepts that we have learned in the last class. Okay, so first we will start with provider. And why you are seeing this particular thing here, why I'm getting auto suggestion, that is because I have used some plugins. So you can also go to your Visual Studio, click on the extensions button. I have explained this on day 1, but I'll repeat it. So search for Terraform. Okay, you will see something here called HashiCorp Terraform, right? This is the official one, HashiCorp Terraform. There are 3.1 million installations. So install this particular thing. And then there is something called HCL, right? Which is HashiCorp language. So I have also installed this. So using both of these things, you will get a lot of automatic suggestions, and you will see auto complete feature as well. So if you see here, if I just write provider and click on this one, the entire indentation part is done, right? And here I just have to name the provider. I can just say the name as the name of the provider as AWS. And once you provide these details, if I just search for reg, you will see that the region field is auto populated. And in the region, I'll just provide it as US East 1. You will see how easy it is to write this entire Terraform project by using all of these plugins and extensions. And this is how DevOps engineers work in the real time, right? So DevOps engineers install all of these plugins, use Visual Studio Code or any IDE. Now, for writing the EC2 instance logic, first thing you need to do is you need to write the resource keyword, right? And in the resource keyword, you see here, because I'm using these plugins and extensions, it is showing me all of these things. I don't even have to go to the AWS official documentation for HashiCorp. So I know that I want to create an instance. So AWS underscore instance. See, I already got it. And let's name this instance as example. And inside the instance, if you don't know what needs to go into the instance, what you will do is you will just search for Terraform space AWS. And here you will go to the AWS provider, and you will have a wonderful documentation here, and just search for AWS underscore instance. Some of these things you will master with the experience, but sorry, where is it? AWS underscore instance. Yep. So here you can see what are the fields, right? You will see what are the mandatory fields. If you just scroll down, you will see the list of fields that are mandatory. There are fields that are optional, deprecated, and there are fields which are not optional, right? So you can scroll down and you can learn through this documentation. But for now, because I already know what fields are required for the AWS instance, let's write that. One is you require AMI. Within AMI block, you can choose a particular AMI, right? But in today's video, we don't want to hard code these fields, right? In the last class, in day one, we have hard coded this using a particular AMI. But in today's video, we will variabilize it. So let's keep it here before I initialize the variables. And then what I'll try to do here is the next thing that is required is the instance type. So instance type, again, I'm not hard coding because I want to make this demo through variables. And finally, in my case, I need a subnet. That is because of my AWS configuration. I have modified the default VPC configuration for some other demo, and unfortunately, I cannot delete that particular thing because I'm continuing with that demonstration for something else. So I need this subnet. In your case, you don't have to mention this. Okay. And if you provide these details, and if you just do Terraform init plan and apply, you will see an AWS EC2 instance will be created. And that's what we did as part of day one. Now let's use variables. So what I'll do is use the keyword called variable, and inside this, write the name of the variable. So for AMI, I want to call the variable name as AMI underscore value. And whenever you are writing a variable, it is important to write the description for that variable, because anyone who is reading your Terraform project, they need to understand what exactly this variable is. So here I'll say value for the AMI. And here you can provide any default thing if it is required. Like you can provide what is a default AMI. But in this case, I don't even want to provide anything default. So let's avoid this. Perfect. And I will create another variable for instance type. Let me call it as instance type underscore value. And you need to mention the description. Value for instance type. And finally, let's use another variable for subnet. I'm repeating again, in your case, this might not be required. Subnet underscore ID underscore value, and just write the description for it. Value for the subnet ID. So I'm just writing some vague description. You can provide the description as precise as possible. You can write it in multiple lines. More you write about these variables, more it is understandable for someone who is reading the project. Perfect. So I have this bunch of variables. Now what I'll do is here I will replace this thing with var.ami value. Here I'll say var.instance type value and var.subnet ID value. So see, by using a IDE, that is by using Visual Studio Code and the plugins that I have mentioned, how simple is this, right? It has become so easy to write 20 lines of Terraform code. We just wrote without even referring to the documentation. So that's the power of using IDE and the extensions, right? And because I'm using code spaces, I don't even have to create a virtual machine, or I don't even have to bother about my personal laptop. Everything is configured here. Now, if you try to execute this particular project, what would happen is, of course, you have provided proper syntax for the provider. You have provided the provider configuration, you have provided the resource, you have all the variables created, but where are the values for the variables, right? There are no values for the variables. One is you can hard code these values. You can say that the default value for the AMI is AMI hyphen XYZ something, which is fine. But in organizations, usually there is a approach of assigning these variables, that is by using the tfvars file, right? Now there are bunch of advantages if you use this file called terraform.tfvars. The advantage is that, if you are providing any default value here, one is, let's say someone forgot to pass the AMI value, right? Uh, Using the Terraform command, when they are running Terraform apply, they can say hyphen var, they can provide this variable name and they can pass this variable name, or through any other ways they can pass this. But if you are using this tfvars, the advantage is that you don't have to, check in this tfvars file to your source code. Like, you can ignore this tfvar file to your GitHub repository, and you can say that if there is any sensitive information, for example, here all of these fields are not so secure. Let's say you have some sensitive information which you don't want to reveal to any other people. You don't want to push such information into a GitHub repository. Even such things, you can put this in the tfvars, and you can say that anyone who want to execute this project, they can create their own tfvars file. I'll show you in a minute, you will understand. So I'll just say AMI value is equals to, in the string, I need to go to AWS console for this. I'll get a AMI value. So I already have two instances that are running. Let's create, two VPCs that are there. Now let's search for EC2. I am just trying to get a AMI value. Click on the instances, click on launch instance, and you can get the Ubuntu AMI value from here or any other AMI. Let's say Ubuntu, and copy it from here. Of course, you can get AMI values in the other way as well. So this is AMI value, right? And then let's move towards, where is this? Sorry. Yeah. Main.tf instance type. Oh, instance type value is equals to T2 micro, because it comes with, this is under the free tier. And then subnet ID value. See, I did not even enter subnet ID value completely, but it is auto populated. And in the subnet ID value, what I can do is I can open VPC configuration. This is again only for my setup. because I'm doing some other thing. In your case, you can ignore the subnet ID. Still, you can create the EC2 instance, right? Let's go to subnets directly and provide one of the subnet details. And if you want to pass any other fields such as key value pair or any other thing, you are feel free to pass that value to your EC2 instance logic that you are writing. What happened? VPC, and within the VPC, I have subnets here. Sorry for this. It's taking a little more time for loading this page. So this is one of the subnet I'll take. So now what will happen when I execute this Terraform project? Like when I use this command called Terraform apply, what will happen is Terraform will automatically look up for this TFVars file. It will understand that, okay, I have to replace these fields, right? AMI value, what Terraform will do is before the execution, it will apply this variables with the values that are in the terraform.tfvars. You can change this name. You can call it dev.tfvars. But if you are doing that, you have to pass that to the Terraform apply command, because by default, Terraform will only look for this particular name called terraform.tfvars. Okay. So this is one of the advantage, that is automatically Terraform will pass this value. Other thing is, let's say for some other project, or let's say that there is a developer XYZ person who want to run this Terraform project. They can simply come to this TFVars file and they can modify it. Or if you are not pushing these things in your documentation in the GitHub repository, you can just tell that particular developer to create a file called terraform.tfvars, and in that file update these three values. Okay. In such case, what will happen? Even if there is any sensitive information, let's say you have information such as access key ID. Okay. You have your AWS access keys, or you have IAM related policy information. All those things you don't have to check into your GitHub repository, and you can tell them that, okay, create a file like this and update your details. Perfect. So now let's try to execute this thing and see. So, okay, another thing what I'll do here is, you might have understood till now what I've written. Now let's take this entire thing, okay, and I will create a different file here, which is called as variables.tf. Now what I am doing here is I am writing this entire Terraform project in a proper structure. Instead of just writing the entire code in the main.tf, I am creating files for variables. I have created variables.tf. For TFVars, where I am passing the values, I have created a different thing. And this is how you have to write things, right? Even in an interview, if your interviewer is asking some questions, this is how you have to write. And in the main.tf, I've written this. If you still want to segregate this, for provider, you can create another file called providers.tf and you can update there. But for now, it's fine. Now, let me try to initialize it. Terraform init. Oh, sorry. I need to go to Day-3 folder, right? Wherever the Terraform project is, you need to go to that project and then call it as Terraform init. Okay, what is it doing? Initializing the backend. Then it understood that your provider is AWS. Now let me do Terraform plan. Always do the Terraform plan, because you will understand what exactly you are going to create before applying. So it is saying one resource to add, and see here carefully, the subnet ID is replaced with the value that I passed. Instance type is replaced with T2 micro. AMI ID is replaced with the AMI that I'm using. So what Terraform did is, Terraform, when it has initialized, it understood that you are using TFVars, and it has replaced these particular values with, replace these variables with these particular values here. Perfect. Now let's try to run the Terraform apply. Terraform apply. And it will ask you, it will give you a prompt for yes or no. And you can mention yes, and you will see that a EC2 instance is created, right? So I have used variables, I've used provider, I've used resources, all the concept, but one thing is left to use, that is output. Okay, I told you in yesterday's class, we can also use the concept of output and print whatever we require. What does that mean? I'll show you in a minute. Now, once Terraform completes the creation here, you will notice Terraform will just tell you that, okay, the input that you have given is created, the project is successful. But what if, as a DevOps engineer, you wrote this entire code for one of your team members? Okay, you wrote this entire thing for one of your team members, and let's say that developer or QE has executed this project, and they will just see this particular output. What does the output say? Apply complete, resource one created, I mean one added, zero changed, and zero destroyed. But what is created? What is the public IP address of this EC2 instance? Let's say they want to understand that, because they don't want to again come to you and say that, hey Abhishek, can you go to EC2 instance? I don't have access to it. Can you go to the EC2 console and tell me what is the public IP address? You don't want to get into those things, right? So you see that a instance is created, right? This is the particular instance. There is only one particular instance here. The other thing, okay, so this is the one that I've created. Other thing I might have previously, I might have created manually, but this is the instance, let's say, that is created. Now, there is no information for the person who has executed the project. So how you can fetch that? So for that, you will use a concept called as outputs in Terraform. Let's see that again. So what I'll do is I will destroy this particular project, and I will add output field, and I will show you how, instead of just saying apply complete one resource added, you can also get the information of the resource that is created. Okay, so it is asking to delete. I'll give the permissions to delete, right? It is deleting this particular instance called 0dd. This is the particular instance it is deleting. Okay, it is not yet initialized, my bad. I thought this is the one that is created, but no problem. So this particular instance would be deleted. Now let's go back. Let's give it a second to delete. Still destroying. Okay, meanwhile, I'll show you how to write that particular outputs.tf file. So again, I'll go to the day3 folder, and inside the day3 folder, I'll create a new file called outputs.tf. Perfect. And here, what I am going to do is I will write output. What is the name of the output that I'm looking for? Let's say I want to get the public IP address. Okay, you can give any name, and here you need to write the value that is required. So value is equals to, how do you need to write is AWS instance, like you need to provide the name of the resource, and once you provide the name of the resource, you will see that it is auto populating. If you don't have the Visual Studio Code setup, then you need to write this AWS instance dot example. But in my case, I don't need to write because it is auto populated. I'm just using it. AWS instance resource dot resource name, followed by what you will try to print. You have all of these options which you can print. Okay, but I want to print the public IP. So I'll just select this option. If you don't know how to print the public IP, here in my case, because I have the setup, I'm just going through this list and I'm just trying to print the public IP. But if you don't know that, you need to go to the documentation and you need to learn about this particular thing. Now, if I go back to the AWS console, let's see if the instance is deleted, because it said it destroyed. Perfect, it is destroyed. Now let's try to create another instance. This time, when I run the particular thing, it has to give me Terraform init, Terraform. I'll not do the apply one more time because I haven't changed anything. So I'll just say Terraform apply. But it's always a good practice to do Terraform plan. Okay. In your organization, when you're working, please don't miss to do Terraform plan. So it is saying one changes to the output where I get public IP address. Now I don't have to delete the infrastructure. I don't have to destroy it. But only reason why I've done it is just to show you people, right? But instead I could have just added the output.tf and I can just re-execute the project. Still it would have given me that. But just to show you from scratch, I've done it. Okay. Now within a minute, you will notice that along with the apply message, you will also see the public IP. Okay, so this is how usually you need to write a Terraform project. See here, one apply complete, one resource is created, and in the output, it has given the public IP address. And you can print n number of resources, whatever you would like to. Done. So this is how you write a project in your organization using all of these things. Now, if you go to day3 folder, you will, let's close these things. These are the provider information, log file information. For now, ignore those things. What are the important files here for now? The main.tf file that I've created, output.tf, state file. We all know what is a state file. It records everything that it is created, that it has created on the cloud provider. Then we have tfvars and variables.tf. Now let's try to modularize this project. Now, why you need to modularize? You might be thinking, but Abhishek, this is a very simple main.tf file. Now, what if I have 100 resources? Okay, along with this particular resource, let's say I have a resource for S3. Okay, let's say I have resource for EKS. I have resources for n number of things, the VPC configuration, everything in the same TF file. Luckily now, this is a very simple project. So in such cases, you have to modularize. If you are not modularizing, I have explained what are the drawbacks, right? You will write the same thing for 10 different development teams. That is not a good practice, right? So to modularize it, what you will do is in the same folder where you are writing the Terraform code, just create a new folder called module, or you can call, like, you can provide any name of the module. Like what I'll do here is I'll call module underscore EC2 instance. Let's call it as modules underscore EC2 instance. Okay. And now what I'll try to do simply is I will move all of these files under modules underscore EC2 instance. Okay. So just move the main.tf to the modules underscore EC2 instance. Of course, I'll make some changes, but let me quickly move and show you. Outputs is moved, tfvars is moved to modules, and finally, I'll also move the variables.tf. Okay. Now, what I've done is everything is under the modules folder, and inside the modules, everything is under the EC2 instance. But I don't have a main.tf file, the proper main.tf file. The main.tf file is available in the module, right? In this module, now you have everything. But let's say I will delete this tfvars file, because whenever you are writing a module, you don't have to write tfvars. People who are executing the modules, they can get the tfvars. Okay. So in the main.tf of the module function, code, I have that I want an EC2 instance, and I have provided what should be the output, right? In the variables, I have defined the variables. Now, any project, any member in your organization, what they can do is, they don't have to write it inside the day3 folder. It can be in another GitHub repository. Anybody can simply create a new folder called, a new file called main.tf. Okay. And in this main.tf, what I'll simply write is provider AWS region AWS East 1, US East 1. Now, meanwhile, let me also delete the Terraform infrastructure, Terraform destroy, so that I want to execute it using modules and show you. Perfect. While it is deleting, let's proceed. And here, instead of resource, what I'll say is module. Okay. What is the name of the module? You can call it as, let's say, EC2 underscore instance. And here comes the important thing. You have to tell Terraform where it has to fetch the module from. If the module, in this case, the modules is just in the modules folder EC2 instance. So this is the folder. But if it is in the GitHub repository, in a different GitHub repository, you have to provide that. Whatever is the path, you have to provide the path for the module. In your case, because we are just modularizing the application, this is in the same folder, right? Under Day-3, you have this module folder, but in your organization, this entire folder can be anywhere else. And when you are executing the modules, either you can create TFVars file, or even here you can pass the values that it has to execute on this module, right? So here I'll just tell that pass these things to the module. AMI value. Oh, I deleted that file, so I have to refetch these things. But I'll show you AMI value, and the next thing would be, what was the next thing that we have done? Instance type value. And finally, the last one is subnet value. Okay, now let's try to replace these things with the actual ones. So if you just go to this instance ID, can I fetch the AMI details here? Yes. You can take any AMI. I'm just randomly taking it. Okay. Instance type value t2.micro, and you can pick up any subnet value here. Just for the easy purpose, I'm trying to collect this information from here itself. Okay. Now, before I execute this module, let me go to the EC2 tab, and let me show you that I refreshed. Everything is getting terminated. There is only one instance that is running. This is the previous instance that I have, right? You can see the name 7431. This is a previous instance. Perfect. Now, what I have done here is, instead of writing the entire Terraform code, right? Now, let's say you are another DevOps engineer, and someone has created this module entire thing in their own folder, right? What you are doing is you are just writing this simple main.tf file, and you are referencing the module that other person has written. But you need to have knowledge on the module that person has written, right? You need to know what is the location of the module. So this is the location of the module, and in that module, in that location of the module, you have main.tf file where it is creating an EC2 instance with these fields are required. That is, AMI is required to be passed, instance type is required to be passed, and subnet is required to be passed. And those things I will try to write in the main.tf file. Okay. So I've written those things in the main.tf file. And now let's try to execute and see. Terraform init. So what is the advantage that we gain here is, next time when someone writes, okay, that person might be writing in this GitHub repository, another GitHub repository, another organization, another GitHub organization completely. What they can do is they can just write this simple code instead of writing the entire thing that we have written in this folder. They don't have to write this particular main.tf. They don't have to write the outputs.tf. They don't have to write variables.tf, tfvars. Nothing should be written. They just need to know how to write this particular block of code. Now let's try to execute Terraform plan. Okay. So it said one resource will be added. Perfect. Now let's try to say Terraform apply. Now it will ask for yes or no. Let's say yes. Now you will notice that because we are consuming this module, the instance will be created. Okay. So 100 members can execute this particular project. 1000 members can execute this project without writing all of these files. They just need to write this simple block of code. So using the modular approach, you are developing reusable code. You are developing easy maintenance, right? Only thing that you need to maintain is this block of code. if this piece of code is written 1,000 times, no problem, because there is nothing here, right? Everything is in this particular module folder, and you can simply maintain this module folder instead of maintaining 1,000 projects. See, it said the instance is created. Let us see if the instance is created or not. You should see 2 instances in running state. See, the new instance is created. So this is how you modularize applications. So if you have, let's say, instead of, in the previous example, when I explained, I just used one particular resource, right? Here I just used one particular resource. What if you had 2 resources? You can create 2 modules. There is no problem. For AWS instance, you have created a module. Similarly, in this module folder, you can create a different GitHub repository just for the modules. There is no problem. You can create a GitHub repository called Terraform modules, and in that you can keep writing all the modules that you want to use in your organization. As a DevOps engineering team, you can do that. For EC2 instance, you can write a module. For VPC, you can write a module. For EKS, you can write a module. And you can just tell the developers that, okay, developers, we have written entire thing for you. All the modules are automated. Now what you need to write is simply a main.tf file. And in the main.tf file, just call the modules that we have written and just pass the values. Okay. You can provide them some documentation and tell them that these are the values that you need to pass. Perfect. So this is how you modularize your infrastructure, your Terraform infrastructure. And please go through this notes one more time. And what I will do is I will publish these things, whatever the project that we have created. I will put this entire thing in the day 3 folder. But please try to do this thing, entire thing on your own. If you just try to execute, if you just go to the day 3 folder and execute it, definitely you'll be able to run it. But just try to repeat the exercise that I've done. Even though you know about modules, let's say you have worked on modules long time back, still try to do that so that you will just try to brush up your knowledge. Okay, so that's all I have for today's demo. Sorry, one thing I forgot. Now, when you are using Terraform Cloud, or let's say you want to use any publicly available modules, what does that mean? Similar to Docker Hub, if you know the concept of Docker images or container images, you all know that there are some publicly hosted images in Docker Hub, right? So this has publicly hosted images and anybody can use it. But technically in the organization, you will very unlikely to use the publicly hosted images because you don't know who are maintaining them. You might create your own images. You can push them to your private registries and you will use from there. Similarly, for Terraform also, you have something called as Terraform registry. You can just search for Terraform registry. And here you have bunch of modules, right? You can just search for EC2 instance. You will find modules similar to what you have developed. Okay. So this is AWS EC2 instance state, but similarly you will find Terraform AWS EC2 instance module as well. It is up to you. It is up to your organization if you want to use this publicly available modules. To use the publicly available modules, it is very simple. Let's say you want to use this particular thing called _instance. Okay, so this is one of the Terraform module for EC2 instance. And if you just go to click on the example button, click on complete, you have the code here, right? You can just come here, copy paste this thing. Anybody can use this particular module, but this is publicly available. So you are not sure if there is any issues. So you have to use it on your own at your own risk. So instead of doing that, what most of the companies do is they write their own modules. Okay, just like I have written now, companies, DevOps engineers, they write their own modules and they put that in a GitHub repository. That will be a private GitHub repository. Right now we are using a public GitHub repository, but usually people use a private GitHub repository, and from there they will reference the modules exactly how I have done, right? Just provide the module path. If it is in the same GitHub repository, use dot and provide the path. If it is in a different, you have to provide the complete path. Got it? So I hope you found today's video informative. Thank you so much for watching the video. And in future classes, we will learn about Terraform state. We will learn about a lot of interesting aspects about Terraform. Stay tuned. Thank you so much. Take care, everyone. Bye bye.